Dear students, C program for linked list insertion. Today we are discussing about the C program to insert a new node in the beginning, at last, and also in a randomized position. Okay, so let's start our program. First, two header files stdio.h and stdlib.h. Standard library for your. We are here in this program. We are using structure, user defined data type, and also lots of syntax is there that all are defined in the header file stdlib. Okay, so this is our node structure. We are using user defined data type structure for creating a new node for our linked list. So the syntax is struct node in data. This is the data field of this particular linked list, and this is the link field. The star next means the pointer that is point to the address of the next node. Okay, next node. Clear? So this is, and here we are closing the struct format and the semicolon. So this is the definition of our node structure, and after that if we want to declare nodes for the linked list, we are declare like that. Struct node star head means we are going to create a head. So here we are initializing and we are not creating, or we are just declaring the head node. Okay, so this four method for insertion and also for display. Big insert for inserting a new node at the beginning, and last insert for at last, inserting a new node at last, and random insert for insert a node at a particular position, and displays for displaying our linked list. Then our void main is starting, void main function. In choices for entering choice, we want to insert or we want to display or we want to insert the at last or at beginning, like that. And this is for our menu purpose, main menu. Choose one option from the following list, and we are printing the options for user to enter. One is for insert in the beginning, 2 is for insert at last, insert at any location for 3, like that. 3 insert at random location, and 4 is for show in, 5 is for exit. And we are scanning the choice here. According to our choice, cases are going to execute. Case 1 is for big insert, case 2 for last insert, case 3 random insert, and case 4 display. Case 5 is exit, and default is we are just printing please enter valid choice. Okay, we are closing switch here and also the while here and our void main function. Then we are going, now the statement is for the function big insert. Okay, so struct node star ptr means we are declaring one more pointer variable that point to a node structure. Okay, one more structure node, and int item for accessing item to store into that new node. And this statement is very important. ptr equal to struct node star malloc size of struct node. After this statement execution only, the memory allocation of the linked list should take in place. Okay, it's only at the runtime, not in the compile time. Okay, so in this, after this statement, node will be available in the computer memory. Maybe the memory is full and we can't allocate a free space to our node, then ptr should be null. At that time we are just printing ptr null. If ptr equal to null, printf overflow. Otherwise we want to add all other details to that node. Okay, we are entering the value and we are accessing the item from the user. That item should be saved in the ptr data field. Okay, and the ptr next field should be head. We have already declared that head is at the first. Okay, only we declared, not initialized or not allocate the memory. So at that time the head should be always null. In this time head is null. So when we are as giving the value head to ptr next means ptr next is null, because we are first only we are creating a new node and new head equal to our ptr, changing the head value by ptr and node inserted. At that time a new node should be created. So this is the big insert format. If it is a very first node, head is null, but we are adding we are inserting a new node at beginning. So at that time head value contains the this PTR. So the second time we are inserting a new node. So new node is PTR. Okay, PTR having the value item. So we are saving PTR data equal to item. Then PTR next equal to head. So the head value now if we are adding a new node. Second time we are adding a new node at first. So the headers contain the old PTR and this new PTR next value hold the previous PTR value. Okay. So head equal to PTR. Clear? Okay. So the next method is for void last insert. Okay. Inserting at last. For that we are declaring two node structure PTR and temp pointer for new node, two nodes. Okay. Item for getting the value. Here PTR equal to struct node malloc size of struct node. If PTR equal to null, printf overflow. Otherwise, we are entering the value and we are saving PTR data equal to item. Okay. So here we are going to insert that node at last. Okay. Maybe at the first time also, maybe sometimes head equal to null means the linked list does not contains any node. It is empty. So at that time also we can insert that node, but as a first node. For that we are if head equal to null, PTR next equal to null. We are inserting very first node and head equal to PTR node inserted. Okay. Otherwise we are just assigning the head value to temp. We are traveling to the very last node. Okay. So because we want to insert that node at last. Okay. So for traveling we are using this step. Temp next node equal to null, temp equal to temp next. We are traveling from one node to another next node like that, and we have reached the very last node. After that, our newly created node is PTR. So the temp contains the very last node. So temp next equal to PTR means now the PTR is our last node, and also PTR next equal to null because PTR is the last node now. Okay, so node is created. That is the last node step. Now the random insert is we are accessing a location. According to that value, we are inserting the new node. Okay. For that, we are declaring an I value and location, integer data type, and also the I and PTR and temp. We are also declaring here. We are allocating a memory to our PTR. Hence, the node has created. So PTR equal to null, printf overflow. Otherwise, enter the elements. We are accessing the element from the user. Item from the user and saving into PTR data field. Hence, we are enter the location after which you want to insert. Okay, we are asking a value from the user like 1, 2, 3, 4 like that. Our node indexes in this particular program, we are node indexes starting from 0. Okay, so 0, 1, 2 like that. So we want to insert a new node after the node with the value 1. Okay, normal concept after the second node, if we want to insert the new node, we are entering the location value as a 1. Okay, and in this loop we are going to travel from first node to that specified location node. Okay, temp equal to temp next. Maybe if temp equal to null, we can print can't insert. Maybe sometimes the user enter the value like 7 or 8 like that. Maybe at that time maybe 2 nodes is there for that linked list. Okay, so we can insert a new node at the 7th position or after the 6th node. Okay, so at that time this if should be executed and return as that we are exiting from that function. Otherwise we have reached the node, that is temp is that node. So after the temp we want to insert the new node. So PTR next equal to temp next. We are changing the PTR next value to the temp next. Temp next means the temp, and after the temp one node is there. So in between we want to insert. Okay, so PTR next equal to temp next means now temp next is, and also the temp next equal to PTR. After this two statement, that node should be inserted. That node has placed there. Okay, so the node inserted. Clear? So that is the random insert. After that, here we are displaying struct node PTR. For display the nodes, head equal to PTR, we are starting from the first node. If PTR equal to null, maybe nothing to print. Maybe the linked list is not contain any nodes. So this if should be executed. Otherwise, printing values are of PTR by a while loop is executing PTR not equal to null. So print of our each node data and we are jumping to the next node, PTR equal to PTR next. So this is all about the display function. Okay. So this is the linked list C program for only for insert a new node and also for displaying our linked list. Execute now. .c .exe. Okay. So we are executing ll executable file. So this is our main menu. Choose one option from the following list. Insert in beginning, insert at last, insert any new lambda and location, show and exit. Okay. So enter your choice. We are entering 1 because we want to insert a new node as a very first node. Okay. Enter the value 10. Okay. So the node is inserted. Okay. So again we want to insert a node at beginning. Okay. Enter your choice. So let's see, we have entered the value 9. Okay. So that 9 also inserted into that linked list. So we want to show now. See, 10 previous time 10 was the first node. Now 9 is the first node. Okay. Now we want to insert at last. Okay. So we are entering 11. Okay. So node inserted. We want to show. Enter your choice. See, 9, 10, 11. The node has inserted at last. Okay. Now we want to insert also one at last. Like enter the value 12. Okay. So our node is now, our linked list is now 9, 10, 11, 12. Okay. So after 10, we want to insert like 100 value. Let's see. For that, I'm choosing 3 and value 100. Okay. So enter the location. Enter the location means I want to enter after 10. I want to create a node after 10. 10 means, so 9 is in the 0th position, 0, 1. So after 1, I want to insert. So I am entering 1. Okay. So node inserted. Let's see. Let's check. See, 9, 10, 100, 11, 12. Okay. So this is all about the insertion C program of linked list. Okay. Clear? Thank you.